Okay, hello everyone. Welcome to this afternoon session of the Invasive Species, Ontario Invasive Species Forum. And today we're starting off with Dr. Kathleen Ryan. Kathleen is a forest entomologist working with Silv-Econ Limited since 2011. She is an expert in invasive forest species detection, ecology, and management. She facilitates a stakeholder working group on hemlock woolly adelgid in southern Ontario, and is other interested stakeholders needed for information and technology transfer. Arnold Ashmore taught us that we need to be prepared in advance for new invaders. To this end, a group of forest managers started meeting in 2014 to identify what they needed to be ready for hemlock woolly adelgid. This is an overview of the HWA addressing those needs and covering the biology, impacts, and detection, as well as other innovations that the group has learned about. So moving to Kathleen's screen here. Kathleen, I think you're still on mute.
Okay.
Oh,
Can you see my PowerPoint?
No, we're on the other screen.
We're on the other screen. Okay. How about this now?
Yep, we can see the PowerPoint now.
Okay, great. All right, good afternoon, everybody. First off, I'd like to thank the Invasive Species Center for putting on this forum, and especially this particular session. I'm really excited to talk about hemlock woolly adelgid, well, more excited to get the word out. As David said, I facilitate a forest managers working group for hemlock woolly adelgid, and so the goals of that group and kind of the plan of action of that group form the narrative of my talk today. Am I doing okay with volume?
Yes, you are.
Okay, great. My slides aren't, here we go. All right, so as David said, our working group first started meeting in 2014, and that was just after there was an initial 2 finds of hemlock woolly adelgid in Ontario. And it was in the wake of emerald ash borer. And I think the big lesson we all learned from emerald ash borer was that we just need to be prepared, or a little bit more prepared for any up and coming invasive species. So the idea with this working group was to form a collaborative stakeholder group, which would provide a forum for information sharing, as well as opportunity to develop some collective goals in order to prepare for the adelgid. So I should say this working group is fairly broad. We've got forest managers from across the province, and we have representatives from the Invasive Species Center and the Invading Species Awareness Program as well. And so when we first met in 2014, we developed a list of what our needs were and a plan of action through that. And we reviewed that since then, and it's still the same. So the biggest need we had was for education. So that's both for forest managers and for the public, so outreach. And it was education across the board. So what's the biology, the impacts, detection, and management tools available? With the idea that the more eyes on the trees, the earlier the detection, the more management options we have. The second, yep.
Just to stop you for a second, we just see the PowerPoint presentation. It's not on the presentation screen.
It's not on the presentation screen. So what do you see?
It's just the PowerPoint. So if you hit the actual presentation button.
Okay, so sorry, I thought I had, okay, here. Now you see it. Okay,
Well, we see the presentation mode. So it's just one
see,
screen over.
all
On the
right.
control panel, you'll be able to switch it.
Okay, what do you see now?
Perfect, that's great.
Perfect. Okay, sorry about that.
No worries.
As you can see, technology is a challenge these days. Okay, so the second big goal is to develop a hemlock database for Ontario. So that's something that simply doesn't exist for any tree species. But if you don't know where the tree is, it's hard to come up with a survey plan, and it's hard to develop management objectives. The third goal we had was to be able to be in a position to provide input about research and management needs around the Adelgid. And something that came up a bit later was the ability to liaise with the different task forces on hemlock woolly Adelgid. Okay, so the first few slides are going to be in the things we wanted to know topic. So here's the Adelgid. This is a picture of the, so can you see my my cursor? Can you see a pointer? No?
We can see the pointer.
Perfect. So this is a picture of the adult once you scrape away that waxy woolly coating that gives the Adelgid its common name. So that's what it looks like. So it's very tiny, think aphid size. And it feeds exclusively on hemlock. And so much like emerald ash borer, it's a pretty serious threat to hemlock species. So it was first detected in eastern North America in the early 50s in Virginia, so right around here where this arrow is. If you've done any reading about hemlock woolly Adelgid, you may come across that it's found in western North America as well, including BC. It's not a serious pest there though, and there's a couple of reasons for that. The main one is it's a different biotype entirely, so the situation is completely different. So this talk is about the eastern lineage of the Adelgid. So this map, if you look at all the colors collectively, that's the range of eastern hemlock species, so eastern and Carolinian hemlock. As you can see from that first, where it was first found, it's expanded through almost the entire range of hemlock to the south, and it's certainly making good inroads to the north as well. Now the spread to the north is a little bit slower because there's some, the cooler climate helps to slow the spread. This was something, as I said, that our working group's been around since 2014 because there was two finds in 2012 and 2013 in Southern Ontario, and that's been managed by CFIA. It wasn't a great surprise that it was here because it's fairly close to us in upstate New York. The big surprise, though, I think was 2017 when it was found through a large area of southwestern Nova Scotia, pretty far from the nearest known infested site over here in Maine. And then jumping forward, it was detected again in 2019 in Southern Ontario. I'm going to leave it at that about the Ontario situation, though, because I know Erin is going to talk about it. So it has pretty severe impacts. As I said, it feeds exclusively on hemlock. And the hemlock it favors the buds, the new growth. So you start to see a lack of new growth in the spring. You'll see needle loss, reduced twig growth, tree dieback. These are all kind of visual cues you can use for foresters and others in the audience that might want to start looking for the Adelgid. And then certainly the tree begins to die back and the tree eventually dies. So from most of the literature in the States, it seems that once the tree is infested, it is almost certainly going to die from the Adelgid attack. Excuse me for a second. Now, how long the tree lives really depends on where it is. So things like climate, cooler climates help the tree to last a little bit longer. Stressed trees, older trees, water stressed trees die more quickly. So now a bit more about the Adelgid itself. So the Adelgid goes through incomplete metamorphosis. So that's egg, nymph, adult. So the newly emerged eggs are called the crawlers. This is a picture of one here. And that's the only actively mobile stage of the insect. Now it can move around the tree or between trees. And it looks for a good place to feed. And it feeds on the twig right at the base of the needle. So if you're looking for the Adelgid in the field, this is where you're going to look. So underside of the twig, base of the needle. Once it finds a good spot to feed, it inserts its mouth parts into the tree. So it's got those piercing, sucking mouth parts. And they're quite long in relation to the size of the insect. So it's putting its mouth parts in, it injects a bit of saliva, which induces a systemic response in the tree. And then it begins to feed on the tree's stored nutrients. It stays in place while it's feeding, and it develops into its adult stage there. It begins to create that white waxy woolly coating that gives it its common name. You can see here a bit of a halo. It's just starting out before it's completely covered, and it develops into the adult stage within that woolly covering and begins to lay its eggs. Okay, this diagram shows a life cycle of the Adelgid. Now the timeline here is fairly approximate. We don't know exactly when it is in Ontario, but this is approximately the case. So I mentioned that it affects only hemlock, and that's true here. In its native range, this biotype, I forgot to mention, it's from southern Japan. And in southern Japan, it actually has an alternate host. So there's a winged morph of the Adelgid that flies away to the alternate host, which is a tiger tail spruce. But as far as we know, it does not have an alternate host here. So for our purposes, we can just ignore this group. Excuse me. So two things to take away from this slide. One is that there's 2 generations per year, so there's a fairly short generation in the spring. And then there's a longer generation that lasts through the rest of the year. What I find the most interesting about it is the second generation. So once the crawler finds a place to feed in the early summer, it actually goes into an estivation or a quiescent period over the summer and doesn't feed, and only begins to feed in October or so, sometime in the fall, and then feeds through the winter. So that's pretty different from most of the other insects we're used to seeing. One take-home point with this slide is that the winter, early spring, late spring is a really good time to start looking for it, because as we talked about, the insect is pretty small. The infestation often starts in the top of the tree. Hemlocks are pretty large, so hard to see. And then on top of that, the nymphs are, as you saw from the previous slide, maybe more difficult to detect. So this time of year becomes the easier time of year to detect it. Sorry, I realize I'm using my cursor on the wrong slide. Okay, so much like many other invasive species here, it's a big problem because there's no effective natural enemy. So there's no parasitoids that attack it. There's some generalist predators, but they don't feed on it enough to really control populations. There is quite a bit of work on predators, though, in the United States for use in biological control of the Adelgid. Eastern hemlock species don't show any resistance to the insect. So those are probably the 2 biggest factors. There's a few other factors I'd throw in there too. One is that it's parthenogenic. So on hemlock, they're all female, so they're not slowed down by having to find a mate in order to reproduce. And also, as we saw in the previous slide, there's 2 generations per year, so that gives it a higher reproductive potential. And the final thing I'd throw in there is that it's really difficult to detect at early stages. So if you're thinking about actual management to inhibit population growth, that can be slowed down by detection challenges. So mortality factors, we're mostly looking at weather, climate sorts of things. So cold winter, so it's feeding through the winter. So cold winters, those cold snaps, especially later in the winter, are cause more mortality. Although the population can certainly rebound in the following year. To maintain the population of the Adelgid, we really only need between 2 and 9% overwinter survival, which is not very many that we need to survive. Anything higher than that can lead to population growth. And then hot summers can be a factor as well, causing mortality. Excuse me. All right, as I mentioned, that crawler stage is really the only actively moving or actively dispersing stage of the insect. And you can imagine if it's moving around on those little legs, it's not going to go very far on its own, but it can certainly be moved around by wind or with birds or mammals that visit the tree. And that's probably, and certainly longer distance dispersal as well, on those with wind events. And birds, and of course infested nursery stock. I was going to say the birds are probably how the Adelgid got to Nova Scotia from that site in Maine. Although the crawler is the only actively mobile stage, the ovisacs can be dislodged from the tree too, and they're kind of sticky. So they certainly do cling to birds, and I would say for us too, we have to be careful. Oops, sorry. Because they can stick to people and to wood products, and we can certainly move them around that way. Okay, so moving into detection. So I've got a couple of slides here on detection, and really what I want to do is just to try and help you solidify your search image for the Adelgid. There's lots of information on visual survey protocols and on ball sampling and other methods of detection online. So I'm not going to go into that. It's pretty easy to find those resources, or you can certainly contact me for some leads about how to find those things. Ball sampling, I have to say, is a pretty fun way to try surveying for the Adelgid. You take a Velcro covered racquetball and you sling it up into the tree with a dog ball launcher, which is pretty fun once you get good at it. Anyway, back to the visual detection. So we talked about the Adelgid causing the absence of new growth in the tree. So that's, if you're looking, there's lots of good survey protocols. So if you have the time to do that, that's great and ideal. But certainly if you're in a forest with hemlock, it's a good idea to start having a look at those hemlock trees to look for signs of infestation. So the trees you want to key in to look at maybe are ones that show an absence of new growth in the spring. Also, if the foliage looks a bit gray or a bit blue from a distance, sometimes that can be an indicator of hemlock woolly Adelgid. And certainly if you think about where animals and birds move, often riparian areas are a good place to start looking, like along shorelines, or just in your yard near a bird feeder would be a good place to start looking as well. So as I mentioned, you're looking at the underside of the twig, and if you're looking up in the tree, oops, sorry, I'm losing my pointer here. You're looking at the underside of the twig. I'd say also have a look at twigs on the ground. A number of us, and probably some of you on the call, were at a field site in upstate New York, and it was a terrible windstorm, but there was many twigs on the ground, and they were all covered with hemlock woolly Adelgid, so that became a very easy way to find it. Okay, and just putting the pictures of the insect life stages onto that life cycle diagram. In the summer, you're probably looking for something like the nymphal stage, whereas in the winter, you're looking for the woolly mass. Now the next slide, actually, I had a little video I was going to show you about detection, but it doesn't play, so I'm just going to skip through that. All right, so management options. Currently, there's, oh shoot, 2 minutes. Okay, so I'm going to skip through that because Michael's going to tell us about some management options. There is one we had wanted to liaise with about our needs around hemlock woolly Adelgid management tools, and one of the things that's coming together pretty soon is a practitioner's guide for hemlock threatened by hemlock woolly Adelgid. So our members of our working group recently met with the collaborators and writers with MNRF and CFS. I'm going to fly through this here because I really want to get to this point. So one of our projects is a hemlock database for Ontario, as I mentioned, and this is what we have so far. So this map, you can see the gray is the expected range of hemlock in Ontario. The green is what we have. So this is a compilation of all sorts of resource inventories out there, provincial, county, municipal, conservation authority. There's iNaturalist reports, observations from the public, all sorts of things. But as you can see, we have quite a few gaps. So Certainly quite a bit of southern Ontario and southwestern Ontario, we don't have much in the way of hemlock inventory. So if you do know of hemlock inventory, if you manage hemlock inventory, please let me know. We'd love to have your data to fill in some of the blanks. This database is actually, with permission of the contributors, it's being used to help, we shared it with CFIA to help bolster their survey work, but more recently we shared it with CFS scientists, so Dennis Yamshamnov and Chris McCory, who are going to use it to identify areas that are higher priority for hemlock woolly adelgid survey. So that'll be useful for both CFIA as well as our county forest managers who can locate areas within each county that are higher, have a higher probability of infestation. Okay, I'm gonna backtrack now that Colin's not waving his 2-minute sign. Oh, he is. Okay, you're back. Okay, so I'll end off here. So if you'd like any more information, this is my email address. There's lots of great resources for hemlock woolly adelgid. Invasive Species Center has a ton of stuff, and there's a bit more on invasiveinsects.ca. Okay, thanks, David. Sorry for the rush.
No worries. Thank you very much. Really appreciate that. Yes, if you want to know more, you can type more questions into the question box, and we can ask questions of Kathleen at the end. So just going into Michael's talk right now. Michael Stasny is from the eastern part of Canada, and he did his BSc at Simon Fraser University and his doctorate in ecology and evolutionary biology at Cornell. And now he's working with the Canadian Forest Services as a forest insect ecologist at the Atlantic Forestry Center in Fredericton. So he's going to give us a talk about the comprehensive pest management strategies and the approaches that the US taking and how we can use those tools to look at both short-term and long-term tactics for managing this pest in Eastern Ontario or Eastern Canada. So I will turn it over to Michael now.
Thank you so much for the introduction.
You're welcome.
And can you see my normal presentation mode now?
Yep, we're good to go.
Perfect. Also, thank you to Kathleen for her introduction, because it allows me to go a little faster through some of the sections. But I thought I would start off with kind of an overview of the situation in Nova Scotia, what we're dealing with, and some of the research that's going on to address this fairly significant threat to the hemlock forests. You might see this in another presentation as well. It just gives you a bit of a spatial scale with Nova Scotia, the 5 regulated counties that have hemlock woolly adelgid. But then, of course, a good reminder is that hemlock woolly adelgid is native to the west coast of Canada and the Pacific Northwest of the United States, where it's been for probably a couple of million years. It's a different strain than the Asian strain that was introduced to the eastern United States and eventually spread to both Ontario and Nova Scotia. But it's kind of a neat part of the biology of this pest. So here's the map of the southwest Nova Scotia, and these were the detections by the CFIA between 2017 and 2018. The insect was detected in 2017, and really by next year already, the extent of its spread throughout that part of the province was quite evident and definitely worrying, because we don't quite know where or even when it was introduced. Clearly, it came from somewhere across the water from Maine, probably hitching a ride on birds. And this is a fairly significant distance, probably 150, 200 kilometers. And once it arrived to Nova Scotia, it was able to spread relatively rapidly unnoticed until 2017. We think that it probably had been there for perhaps even a decade prior to that. By following year, it's like my, okay, there we go. By following year, we see more sites. Now it's more inland towards the Kejimkujik National Park and some of the adjacent wilderness areas, protected areas in Nova Scotia. And by that point, we're already seeing some mortality. And these trees were actually, this was a picture I took in 2018, my first time visiting some of these sites, and already we're seeing some of the hemlock dying towards the very southwestern part of the province. More detection sites the following year. We're getting into 2020. And so the spread has been quite fast, although it's difficult to tell how much of it is spread and how much of it is just increased detections, because this pest is definitely relatively inconspicuous until you see actual signs of the infestation, or you see some branches with those waxy clumps on them. So it might have easily gone undetected at many of these sites for a number of years. And this past year, definitely significant numbers now more inland, and it's starting to actually get into 6th county on the list. It's just across its border. So there's some decisions to be made about the regulation in the province. I'm just zooming in on the same region, showing the extent of hemlock. You can see it's quite patchy, but it's very spread out. It's ecologically a very important species in this this region. A lot of the stands are quite small, and then it's very typical of hemlock to be sort of in these clumps or along riparian zones in the region. In 2018, Nova Scotia Department of Lands and Forestry did aerial surveys over this area to see the extent of what they're calling defoliation, but it's really sort of the crown thinning that you see as a result of the stress that the tree is experiencing due to the feeding by the pest. And you can see that by that point, this is really just a year after the first detection. You can see that there's a number of stands that show fairly substantial damage by that point. And they've also looked at, I'm just removing the hemlock layer from the map so it's a little clearer. You can see that it extends quite far inland into some of the more eastern parts of the current invaded range. And then looking at mortality, so this is tree mortality, you can also see that there are a few hotspots where by 2018 there were already trees evident from the air that were dying or dead. The department repeated these aerial surveys in 2020, but it looks quite different simply because they were flying different flight paths. There were different observers on the plane. So there are a few issues in being able to compare these two different years of surveys, but it's still significant to see that, again, we're seeing defoliation or damage from the air. The other thing to note is that there may also be a period of recovery, sort of temporary recovery on the part of the hemlock. And so it could be that one year you see more damage than the following year. But the progression is definitely towards increased decline and eventually mortality. And when they surveyed the mortality of the trees in that year, in 2020, you can see that there are now some areas that were definitely spread out throughout this this region where we have the pest. So it's not just a clump of sites where, for whatever reason, the trees were more stressed to begin with. We're seeing it in a number of stands. And so one of the challenges that we're facing in Nova Scotia is that both the hemlock and, of course, the insect pests are very patchy in their distribution. That makes detection quite difficult. The way that HWA disperses on birds and with wind and so on, as Kathleen highlighted, makes it really quite difficult to control. The early detection is very difficult, and eradication is really difficult. It really is one of those species where just because you find a local infestation and you try to delineate it and get rid of it, the chances that you have actually 100% controlled it locally are quite unfavorable. Some of this temporary recovery of the hemlock may hide the impacts of the pest. So we can see a bit of a regrowth on the trees, but then they might, again, the following year start to decline further because the populations bounce back. And it basically just can happen in advanced stages of infestation. There's so much feeding that the tree declines, there's mortality of the pest, and then the tree can recover a little bit. Once it starts recovering, the populations of the pest build up again. The mortality we're seeing is certainly occurring within probably several years, at least at some of the sites, and there are some important stressors that contribute to that, especially drought, and this region has had a number of important droughts in the last 5 to 10 years. It's a real mix of private and public land. Some of the forest is managed for timber, but there are also large protected areas, and some of the interior of this region is actually really quite remote and not easy to access for any sort of pest management. And so from the beginning, we've known that we need more empirical studies and we need to integrate management strategies to tackle this problem, because the experience from the United States has shown that this is not an easy pest to deal with, and even 2 or 3 decades of research and pest management programs have not stopped its spread yet, and we're still seeing more impacts. So we've had a couple of different management plans that came out in the last 2 or 3 years. There's also a new one that we're just revising for Nova Scotia specifically. But some of the ideas in these frameworks were more research so that we can figure out what kinds of tools could be used and what kinds of things might work. Biological control is on the list, of course, and so this would involve introducing natural enemies that would keep the populations below levels that cause the decline of the trees, and they would be involving release of these specialized predators from the native range of the pest, either from Western North America or from Asia. This is a major undertaking. It's quite expensive to go through all the host specificity testing, rearing of the predators, the releases, monitoring, and so on. But the advantage, of course, is that we would be building on the previous or existing programs in the US, and so we don't have to make quite as many errors. We just need to figure out what works best. And it is ultimately the only long-term solution that you can implement at the landscape scale. The one tricky part, and Kathleen already mentioned the really complicated life cycle of the pest, is that we really need to be able to regulate both generations, both the progredients and the Stents, because if only one of them is impacted by the biocontrol, the other one seems to rebound really quite easily and doesn't make that much of an impact. This is from the New York State Hemlock Initiative, looking at how the 2 different biocontrol agents, Laricobius beetles and Leucopus silverflies, would be addressing these 2 different life stages. One would be basically during the fall and winter, predating on Stents, and the other one would be through spring and into summer, causing mortality of both Stents and the progredients, thereby reducing the overall population. And so we're currently working together with Lucas Roscoe and Jeff Fidgen at the Atlantic Forestry Center on describing this complex of native natural enemies that already exist in Nova Scotia, and that's just one of the early steps of this kind of research. We're sampling over time what kinds of predators are we seeing on these hemlock branches, but we already know from the next step, which is evaluating the impact of population, we already know that clearly the control by the native natural enemies is insufficient in preventing these infestations and spread. And so this kind of research would basically go towards a petition that is then submitted to CFIA, and we can assess the feasibility and the future of launching a biocontrol program identifying predators in BC or in Asia. An important component of that is looking at phenology of the pest, so the timing of life stages, and this is work done especially by Jeff Ogden with the province, and Celia Boone, looking at these spikes in the population represented by the different life stages of the insect. There's some differences among years, but we're starting to see a fairly significant pattern of how they're spread out over time. And that allows us to think, okay, what would be the important timing of biocontrol agents, for example, in the future to impact some of these life stages. And the comparison of this phenology across region is quite interesting because Nova Scotia actually stands out quite a bit as a fairly unique region. The systems they run into early summer, which is quite different from Virginia or Connecticut or even BC, and it's quite a protracted life stage. And they also actually overlap with the progredience stage, which we don't really see in any other region. So that makes probably for climatic reasons, Nova Scotia to be a relatively different, distinct region compared to the others. And as we think about these predator-prey relationships, the one thing that will come up in the future is trying to match the climatic zones of the infested region. So the plant hardiness zones of 5B and 6A in Nova Scotia, or 6A and 6B in Ontario. If we're, let's say, sourcing populations of predators from BC, we may want to find some interior populations that have similar plant hardiness zones to match the climate of the predators, and because of that, hopefully their phenology to the situation in Nova Scotia. John Sweeney, in collaboration with Chris McQuarrie and Chris Edge, are working on chemical control. I'll just very quickly go through that approach, and this has been done with quite a bit of success in the US. The one distinction is that in Canada, some of the insecticides are not permitted, and so we're looking at research that could potentially open up new use of insecticides that at this point we can't use in Canada. And of course, we're looking at various impacts on non-target aquatic and terrestrial arthropods because of obvious concerns. And so there are research trials already underway in both Nova Scotia and Ontario, testing the efficacy of a couple of different products that could be applied to control hemlock woolly Adelgid. Again, this is a tech that can work on individual trees or individual stands, but it becomes prohibitively expensive to apply to larger areas of forest. Now for the rest of the talk, I'll get into the silvicultural control, which is this idea that promoting hemlock vigor would be one of the ways in which we can mitigate these impacts of the pest. And the rationale is actually pretty simple. As Kathleen already mentioned, each of these little insects basically taps into cells that are right at the base of the needles, this parenchyma cell of the rays that provide nutrients into the needle and take photosynthate out of the needle. And so as the insect feeds at this crucial conduit of resources, it basically leads to carbon starvation. It really changes the dynamics of how the nutrients are stored within the tree. And importantly, it alters water relations. And so this is what causes that stress that then translates into reduced growth, needle loss that eventually dieback of the crown. And so the idea behind silvicultural control is that we could open up the canopy to promote tree vigor by reducing competition for both light and water. And there's some evidence showing that more vigorous trees tend to be those that succumb to the pest slower than the other ones. They still tend to die in the end, but it may take quite a bit longer, and this just buys us time to try some other tools to protect them. There are a couple of lines of research from the US that have supported that. There's one experiment that's been done in the Northeast. It still has results that are kind of pending, but there's some evidence that the trees show better growth rates under the thinned conditions. There's better evidence for that from another experiment that's a little bit more south, where they're seeing trees that were released competitively by creating these gaps around them are seeing up to a 9-fold increase in growth. They're seeing better photosynthesis, carbon balance, and so on. This is in stands that already have biocontrol, and so they're trying to look at whether that could be an additive benefit in addition to the biocontrol or not, but the results so far are quite encouraging. And then the other thing that is hoped through this control is also that the elevated light levels and the exposure to the elements is actually suppressing the populations of the pest as well. And so what we've started in Nova Scotia is this field trial of thinning hemlock stands. This is a longer term study that we intentionally wanted to do at an operational scale. And it's very much a preemptive approach. So we're thinning prior to any real decline in the hemlock because the trees need time to acclimate first before they can start showing any kind of resilience to the insect. And hopefully it could be integrated with other approaches. So for example, chemical control or biocontrol. And this is kind of in the future, providing that we're seeing encouraging results. We now have 8 research sites. 4 of them are private and 4 of them are on Crown land. They range from 30 to 70% hemlock, so they're not pure hemlock stands. And they have either light infestations or no infestations yet, but proximity to known hotspots of HWA, so it's likely that they'll be infested sometime in the near future. And then at each of these sites, we're pairing a control plot and a thin plot, each of them surrounded by a buffer that receives the same respective treatment, either unthinned or thinned. And harvesting prescription is removing 20 to 40% basal area, either done through selection harvest or shilter wood. And in doing so, we prioritize the removal of the competing low vigor trees. They tend to be not hemlock, they tend to be, let's say, fir or maple or birch and so on. Or they might be hemlock that's simply showing lower vigor or might be actually showing some higher infestations. And at each of these sites, we're monitoring infestations and tree condition in 20 to 30 high vigor hemlocks that we selected randomly, other than considering sort of more vigorous trees. And we monitor the densities of the pest, production of the new shoots, live crown ratio, so basically the extent of good shoot production in the crown. And we're also starting to collect baseline data on understory vegetation, regeneration, abiotic conditions in the soil, and so on. And so this is a longer term project. We're looking at a time frame of at least a decade before we see any obvious responses, but we're optimistic that this could be one of those tools that could be used in combination with other tactics that we might have by that point. And so besides the 2 obvious goals, which was to basically boost the growth of the trees and increase the tolerance to the pest by reducing this water stress and competition for light, and also increase the mortality of the pest due to just exposure to the elements. There are also a couple of additional goals that are worth mentioning because I think they help to look at the situation of this invasive pest in the context of public outreach, communication with woodlot owners, and so on. One is that this would discourage preemptive harvesting of hemlock stands that some people might be tempted to do as the pest gets into their area. They may want to just harvest all the hemlock so they don't have to deal with dying trees later on. And this is basically then eliminating the possibility that we might find resistant genotypes that could help us in looking at some of the other options of restoring these stands. So this gives the woodlot owners not necessarily false hope, but rather an alternative route they could pursue. And it also promotes consciously sort of planning strategies for regeneration in those stands. And then in the long run, that could help with restoration and rehabilitation because it's likely we will lose some of the hemlocks, but at least anyone that already has done some of this thinning in their stands is more actively thinking about what kinds of trees are coming in afterwards, what kind of habitat integrity am I trying to achieve or maintain, and so on. And so the future work and that we have ahead of us and the long-term prospects, they're quite discouraging in the sense that we know from the US that there's no silver bullet. We need an integration of multiple management tactics to make any kind of a difference. And because there's already a fairly large area in Nova Scotia that's been where the pest has made some real impacts, it's likely to be not quite on time for some of those regions. We'll certainly see trees lost before we have any ability to prevent that other than through, let's say, the use of insecticides. We also need to start thinking more about seed conservation. So out here in Fredericton, we have the National Seed Center that's collecting seed from hemlock to preserve the genetic diversity in the region, which we know is actually quite low, so it's not really good news. But if we find any genotypes that are showing resistance to HWA, again, this would be very important to then try to see if we can propagate those genotypes and start to think in the long term about some tree improvement programs that would be targeting hemlock and resistance to the hemlock woolly adelgid. We're also looking now at kind of a more broad perspective of looking at how can we understand and mitigate the impacts of the invasive species on the habitat and the ecosystem that's associated with this foundational species. So that's a major concern, especially in this part of Nova Scotia where we have a number of important protected areas and wilderness areas, including Kejimkujik National Park and Tobiatic Wilderness Area. And finally, we're trying to prioritize restoration and rehabilitation wherever we're already seeing that the impacts are becoming evident. So one of the things that's difficult or discouraging to do is basically racing to rescue stands that where it just might be too late. And instead we need to think about the, next decade or 2 decades, what happens to those stands afterwards. So I'll end it there. I'll just thank a bunch of partners that helped us with this research. And again, I'll be happy to take any questions later on. Thank you.
Thank you very much. I'm going to have to go off video right now just for the fact that my internet went out. So I'm changing my upload a little bit, which is good. But up next, we have Erin Appleton. Erin is part of the CFIA. She did her master's at the University of Guelph in plant agriculture. She's been a plant survey biologist for 15 years and is now the acting national manager for the Plant Health Surveillance Unit. Erin leads a number of highly visible pest files, and she loves the creative and collaborative opportunities that it provides. Hemlock woolly adelgid is a destructive plant pest regulated under the Plant Protection Act. The CFIA conducts surveys, develops outreach and educational products, and establishes partners to support regulatory controls and connect to different response plans for the pests. So I'm going to give it to Erin and she can take it away.
Thanks, David. Okay, everyone can hear me. It's great that Kathleen and Michael really set the stage, and now I can highlight some of the ways in which the Canadian Food Inspection Agency contributes to the hemlock woolly adelgid file. I'll start out by providing an update or overview on the Canadian Food Inspection Agency's legislative authority by which we regulate hemlock woolly adelgid. And then I'll get into highlighting the ways in which we prepare for hemlock woolly adelgid, share information, and do collective outreach and education with our partners. I'd like to provide a brief overview on our survey methodology and some of the key results of 2020 and our plans for 2021. A brief overview of the current status in Ontario, knowing that Michael already highlighted the Nova Scotia situation, and then finish off with some collaborative response measures we hope to move forward, as well as ongoing priorities. So the Canadian Food Inspection Agency aims to mitigate risk to Canada's plant resource base, which is integral to a safe and accessible food supply, as well as public health and environmental sustainability. The section of the Act that's most relevant to all of us as citizens is Section 5, the duty to notify the minister. And this means that any of us that may become aware of a potential quarantine or regulated pest within a new distribution should notify the minister, and is obligated to do such through the Canadian Food Inspection Agency. Our regulations are intended to slow the spread and protect non-infested areas of Canada. So Kathleen provided an overview that we have the BC strain, which are regulated by infested places order, in addition to the introduced populations in Eastern Canada and Ontario. So we have 2 infested places orders established in Ontario, the township of Wainfleet and Niagara Falls, as well as that in Nova Scotia, southern Nova Scotia, which Arvind will touch on as far as regulatory updates in response to the new findings. Our policy directive, DO 705, outlines phytosanitary requirements to prevent the introduction and spread of hemlock woolly adelgid from the US as well as within Canada. And this stipulates regulated articles, phytosanitary measures that are employed to mitigate the risk, as well as movement restrictions that are defined to prevent the movement of regulated materials out of regulated areas. Partnerships have been incredibly important as far as preparing, planning for, and responding to hemlock woolly adelgid. We endeavor to conduct a lot of knowledge transfer and information sharing with our partners, training one another as far as collaborative surveillance strategies, and then supporting our collective outreach education needs to feed into research as well as response measures. One of the formalized systems we've developed to coordinate multi-government information sharing and actions is the establishment of a technical advisory committee. And this pest-specific group makes recommendations to senior leaders. We pool our expertise and resources to help facilitate response and support research advancements. This group also provides scientific or technical contributions towards the management of hemlock woolly adelgid. We have a very broad membership with representatives from across Canada, as well as expertise we are thankful to have from our colleagues in the United States. So the hemlock woolly adelgid task force is another layer by which a group of specialists has the capacity to analyze incursions, provide science and technical advice to direct our collaborative efforts, facilitate collaborative implementation of management plans in response to new detections. So these are site-specific adaptations of those broader management plans that Michael highlighted. And also the task force strives to facilitate support advancements in hemlock woolly adelgid management, including chemical and biological control. As far as outreach, we continue to work with our partners, but we have developed some products in-house to really promote awareness on this pest and encourage reports to foster early detection and rapid response. We have metal signs that can be used by partners and interest groups along trail systems and in high-risk areas to provide information on the pest and how to report it. We have pest cards that we produce large quantities of for broad-scale distribution. We share these with groups like Kathleen's as well to ensure that we're really getting the message out through our respective networks. We also work with partners like the Invasive Species Center and others on collective messaging through social media, and we develop collaborative products, so ensuring that we can have a one-stop shop as addressing all of our collective informational needs. As well, we like to contribute to citizen science, both passively through outreach and education, but also through targeted reporting campaigns. And in some ways, we've done this through integration of regulatory content into citizen-based reporting apps like EdMaps, as well as iNaturalist and other platforms that citizens may use to report on invasive species incursions. As far as education, we've tried over the past number of years to have a collective learning framework with our partners to ensure that we all have the same search image and we all have an equal awareness on the methodologies that can be used to detect this pest in the environment. In some ways, we fostered this awareness through creation of simulation sites, so simulating or mimicking the appearance of hemlock woolly adelgid in the environment. The M&Ms are actually used to pay the little kids to roll the tiny cotton balls. So if anyone wants to replicate this technique, those are an asset. With respect to our national surveillance program for hemlock woolly adelgid, we conduct visual surveys between March and May in Eastern Canada. In some cases, we enhance our detection efficacy in high-risk areas by integrating other methods, some of those noted by Kathleen, including fall sampling, climbing, branch sampling. We conducted visual assessments at 204 sites across Canada, 90 of which were in Ontario. And as you can see, there were no new detections in 2020, which is positive news. So when we assess the stand, our staff look at the undersides of 2 branches per tree, inspected for all those signs and symptoms that Kathleen highlighted. We've also found it's incredibly useful to examine the bark of the bole and twigs that have fallen on the ground. This is really obvious and evident in infested stands, and we find it to be a great way to assess the stand level. We target our surveys at nurseries importing hemlock from infested or regulated areas, including BC, Nova Scotia, and the United States. We look at urban parks and green spaces containing hemlock, and more specifically, we focus on hemlock forests within 100 kilometers of the US border, biasing that work to areas that have the greatest probability of an introduction. When we assess forests, we do a little homework in advance, compiling any imagery or background information we can that will help us in dividing the stand to assess it more effectively when on site. Often we'll divide a survey area into 4 blocks, surveying the stand in a zigzagging pattern and examining the nearest hemlock every 25 to 50 steps with the objective to assess 100 trees in a stand. We know that because hemlock woolly adelgid is clumped and hard to detect at low levels, it's really beneficial to spread out your sample points, focus on edges of stands, waterways, and trails, and that kind of hones you into the pathway-based detection, so where birds, small mammals, and other animals may move and spread the pest. So Kathleen highlighted some of this, but this all builds into our formula for site selection. We can see her database has been built up quite a bit in Southern Ontario, so my map is slightly outdated, but we look at hemlock distribution, areas at risk based on US infestations, as well as Nova Scotia and Ontario, and then analyze migratory bird corridors, overlaying all this information to assess which will be our annual priorities, knowing that we rotate site selection on an annual basis. We are really serious about taking biosecurity precautions. This is actual hemlock woolly adelgid wool on my colleague in BC. Because the highest risks of egg and crawlers exist between April and September, this is even more critical to ensure that people are just taking extreme measures to make certain they're not moving the pest from one stand to another, including, laundering clothes, having lint rollers as part of your toolkit, not taking any samples. CFIA should be contacted in the event of any suspect finds. Light colored clothing worn in the stands can assist with detecting and removing crawlers, and we encourage laundering of clothes prior to re-entering the field. For any of our partners or collaborators interested in conducting surveys for hemlock woolly adelgid, we encourage you to reach out to us and obtain our survey protocol, which enables us all to work from a common framework, a common survey methodology, whereby we can then report on our collective results at the national level. So we're always welcoming partner data. If any surveys for hemlock woolly adelgid or other regulatory pests have been done, we like to compile that and report it as such in our annual report. So a brief look at the history of detections in Ontario. We had our first incursion noted in 2012. It was a nursery stock introduction at a residence in Etobicoke, and the infested trees on this property were quickly removed through a collaborative effort, and that area has been monitored on an ongoing basis. This was followed by the detections we've spoken of in Niagara Gorge that we began noting through our National Detection Survey in 2013. Through the great collaboration with Niagara Parks Commission, the infested trees were removed and burned on site. And then in the following years, we had additional positives, which reflected the trees adjacent to the positive ones. So again, those were removed and burned on site, and extensive surveys were ongoing until 2019, where we had 2 infestations detected. Upon the initial detection, notices of prohibition of movement were issued as an interim measure while the infested places orders were established to regulate those findings. And then, as I mentioned earlier, we had no new reports in 2020, so we're moving forward with response to those finds. Just to give you a bit of background on the finds, the Niagara Glen population was detected about 500 meters from the previous positive. The populations were thought to be low to moderate on the infested trees. At this location, with the challenging topography, hemlock is randomly distributed throughout the mixed stand, and with Niagara Parks Commission, a collaborative long-term suppression strategy is being developed. The Wainfleet location is a bit different. Hemlock is fairly dominant at this site, and the infested trees exhibited moderate to high levels of hemlock woolly adelgid. This site is very wet, and those conditions pose challenges as far as monitoring and control. We can see, based on these ortho photographs shared with me by Niagara Peninsula Conservation Authority, hemlock has been established at this site for a very long time. The one dating back to 1934, you can see that large patch of hemlock there at the northern portion of the site. So I just wanted to highlight that a lot of really great collaborative work is ramping up at this location. We have a great complement of interested individuals from Niagara Nature Club, as well as students from Niagara College who are doing some coursework to help monitor the situation in that stand. And they're actually evaluating the level of infestation and plotting changes over time with the hope to perform some UAV flights on this stand and compare with results from 2019. In addition, we have Ontario Nature working to establish a hemlock preservation strategy for the site, and Niagara Peninsula Conservation Authority working to collectively manage the situation at this stand. So as far as response, a 2-tiered approach is warranted. Site-specific actions are needed to contain the infestation and prevent spread to neighboring hemlock stands. Provincial activities can support early detection and protect the hemlock resource. The site owners are in the process of defining management objectives, considering both chemical and mechanical treatment options, pending biological control studies in Ontario. A decision framework to identify and support treatment zones is under consideration, and through a collaborative effort with Canadian Forest Service and the Ontario Ministry of Natural Resources and Forestry, best management practices for landowners are under development. So as I highlighted, we have great partners collectively acting on this pest at the site to support hemlock woolly adelgid and predator monitoring. The great network is making a lot of progress, hoping to do a lot more over the next couple of months. We are really thankful for this work, and will continue to work together to define the best approach for these stands. So our current priorities involve defining key response strategies and mechanisms for implementation to support hemlock preservation in Ontario. An economic analysis of control measures to evaluate potential economic and ecological impacts of hemlock woolly adelgid is underway. We're working to prioritize activities, define roles and responsibilities, and establish cost estimates with respect to research, enhanced monitoring and data sharing, inventory, education and outreach, as well as response, including host preservation via all of the control measures we've noted already. So as far as enhanced monitoring, a sampling plan to estimate hemlock woolly adelgid density and to quantify hemlock is essential. Monitoring of plots will hopefully be considered to assess hemlock health in proximity to infested or high-risk areas. We're also hoping for some phenology monitoring for crawlers in late August, early September, because we don't have that data for Ontario. And as Michael highlighted, we're seeing some interesting things in Nova Scotia, so it would be good to assess in Ontario as well. The site managers will help support the monitoring through their networks, as I noted. Inventory is key. We're looking at potential for a citizen-based hemlock inventory challenge and also considering other methods to augment inventory, including aerial images, remote sensing, or a targeted reporting project. Compiling occurrence data on beech hemlock stands in Southern Ontario is being considered. As Dr. Sharon Reed noted, this could be a major challenge as far as managing beech hemlock stands to look at the cumulative effects of invasive pests. And for the future, ground truthing is essential to verify that inventory data is comprehensive and complete. So finally, Michael noted biological control, and my colleague in British Columbia, Troy Komodo, has been doing some work to support this as far as CFIA contributions to this project. We know that hemlock woolly adelgid is native to British Columbia, so Troy has been monitoring for moderate to heavy infestations in the hope to locate populations of both Leucopas and Laricovius for eventual release of these predators in eastern Canada. In addition to that work, Troy has been working with Mark Whitmore at Cornell to develop a Leucopas trap that can help increase efficiencies in finding predator populations in BC and possibly use this to assess the establishment and efficacy of released predators. So in 2021, tests will assess whether tree host volatiles, so the monoterpenes, can increase trap attraction. And that's all for my portion of this panel. And if you have any questions, I'll turn it to David to see if there's time.
Thank you very much, Erin. That was really great. Erin's contact information is up on the screen, and if you have more questions to ask her, please put them in the question box, and we'll be able to answer those questions at the end. We'll also be able to answer any other questions that you have when it comes to any of the other speakers that we've had today. So the next person that we have on our schedule is Arvind Vasudevan, and he is currently at the CFIA, the Canadian Food Inspection Agency, as a senior specialist for the forestry program. He has been there for the past 10 years, and he has experience in the plant health program at the CFIA in various different roles. Prior to joining the government, he was at the Lake Abitibi Forest Model in Cochrane, Ontario. At the Canadian Food Inspection Agency Forestry Program, they support the importation and exportation of forestry products while preventing the introduction and spread of regulated pests in Canada. They use science-based regulations that facilitate safe trade by implementing import, export, and domestic movement requirements for at-risk forest products. His presentation will be focusing on the regulatory tools and recent updates to the regulations for hemlock woolly adelgid and other pests. So I will pass it on to Arvind, and
great, thank you, David. I'm going to start sharing my screen.
Perfect, we can see it.
So is everyone able to see the screen?
Yes.
Okay, perfect. Thanks. So good afternoon, everyone. Today, I'm going to be talking a little bit more, zooming out from HWA and looking at the overview of CFIA's role in forest pest regulations, and also the linkages between federal, international plant protection authorities, and the requirements, obligations, and the regulatory tools that are available for us to do our job here at the CFIA. And then I will focus back again and focus on some of the regulatory status of pests that are regulated by Canada and Ontario, and give you a few examples as to the regulatory changes that have been made. So the Canadian Food Inspection Agency is the plant protection authority in Canada, and it is a key science-based regulatory agency, and it has a broad mandate focusing on Canada's food supply, animals, plants, and forests. And we are situated all across Canada. We have 4 major areas that we work under: the Western area, Ontario, Quebec, and Atlantic areas. And the head office is based out of the NCR in Ottawa here. And we have currently 17 regional offices and 132 field offices. And there are about 13 laboratories that are also part of the CFIA. So CFIA's core responsibilities, like I mentioned, for this talk, it's going to primarily be on plant health, but then we also do animal health, food safety, and a major component is international trade. And then at any given time, we have to have multiple hats. We are sometimes a regulator, a risk manager, and also a facilitator. As a regulator, we set rules, verify compliances with those rules. As a risk manager, we safeguard diverse public risks related to public health as well, economics, plant health, and the environment. And then as a facilitator, we try to improve the regulatory interface with international organizations and trading partners. And I'll get a little bit more into it. So ultimately, our goal is to maintain a safe, high quality, pest-free product in international trade. So getting into CFIA's plant protection mandate, we protect Canada's agriculture and forestry sectors, natural resources, and from the economic and environmental impact of introduced pests. And this can never be done alone. It involves a lot of interactions, and like even from Erin's example, you could see the number of stakeholders and partners that we deal with for one particular pest, and that kind of is multiplied and amplified when we deal with the multiple pests. So we engage a lot and we consult a lot, and that is an important part, an integral part of our mandate. And we also regulate import, export, and domestic movement of pests. And we also, like I mentioned, the trade aspect, facilitate access to foreign markets through phytosanitary perspectives. And then, like I mentioned, we also do a lot of international engagement, and Canada is a member of the International Plant Protection Convention, and CFIA is Canada's representative, and it is called as the National Plant Protection Organization. And we work with international partners on phytosanitary issues bilaterally and multilaterally. And then we also work something called as regional plant protection organizations, and Canada is a member of NAPO, the North American National Plant Protection Organizations, and there are 3 members with it, Canada, the United States, and Mexico. And likewise, the European Union is also organized, and they are called as the EPO, the European Plant Protection Organizations. So we all kind of like work together under the IPPC. So what is the IPPC? IPPC is the International Plant Protection Authority for the world. And IPPC, when we say IPPC, it kind of like means 2 things. It means the document which is an international treaty, and it's also an organization, a standard setting organization. And under the international treaty, the contracting parties are always bound by obligations of the convention. And the three main aims that they focus on is prevent introduction and spread of pests, promote fair and safe trade, protect plant life. And under the organization, the standard setting body focuses on ISPMs, international standards on phytosanitary measures, which kind of like lays out the rule or standards for countries to interact and do trade, and also control the spread of pests. And going a little bit more into detail of the scope of the IPPC, it extends to items capable of harboring pests as well, including storage spaces and conveyances. And you might have heard some time back with regards to storage places. It's part and parcel of how we regulate a pest. And a clear example is the Asian gypsy moth and the sea container initiative. And includes intentional introduction of organisms as well, the biological control organisms, sharing of information like we just heard about work that is done in the US with regards to the release of biological control organisms, research, and covers a wide range of plants and protects them from a wide range of pests. And when we talk about plants, it talks about cultivated plants moving in trade and as well as wild flora and protecting resource base. Plant pests include invertebrates, diseases, weeds, and diseases could be bacterial, fungal, or viral. And then with regards to harm, includes direct and indirect effects. And getting into a little bit more of the key principles for IPPC, countries always have the right to use the appropriate phytosanitary measure. These measures should be technically justifiable, no more restrictive than necessary to address a risk, be non-discriminatory and transparent. And countries have the obligation to establish a national plant protection organization. Like I mentioned, Canada's representative is the CFIA, and follow the IPPC standards and develop it under the ISPMs, which I also mentioned, publish the phytosanitary requirements. And those are the directives that I'll be talking about, which Canada does, the policy, which could be a directive or could be a risk management document. And share information on pests and regulations. There is a duty to report at the international level as well with regards to trade, and conduct surveillance, treatments, and certify exports. And when we talk about certification of exports, it is the issuance of phytosanitary certificates. And the phytosanitary certificates are kind of like a currency that is used in international trade for movement of plant products. Erin covered a little bit of this. Canada's requirement to report pests is important, and it is under the Plant Protection Act. And why is it important? It kind of like ties really close with the prevention aspect and the eradication aspect, because we need to know it right away to act on it. So the importance is time is of the essence, and reporting when you notice a pest is very important. And that is why it's kind of like laid out clearly, and it's stressed a couple of times. So, and when we talk about pests, IPPC defines pest as well. Under the Plant Protection Act, it is anything that is injurious or potentially injurious, which directly or indirectly affects a plant or plant product or byproducts of plants. Under IPPC, we also define the pest, and we also define quarantine pest. A quarantine pest is a pest of potential economic importance to the area and endangered hereby, and not yet present there or present, but not widely distributed and being officially controlled. When we are officially controlling a pest, it's a duty to report. And based on the economic importance, we can employ various tools that could be import requirements, restrictions of movement, and any of that categories that would fall under the quarantine pest category. And like I mentioned, where there is a duty for the citizen to report, CFIA's duty to report nationally as well as internationally occurs, and we do it with a bunch of maps. and you would have probably seen this map a little bit earlier. This is a map of EAB regulated areas in Canada. And we also publish the directives, and we also maintain a nationally a national plant pest regulated list, which has all the pests that are regulated by Canada, and it's available on our website with links to the various directives that are associated with that particular pest. And like I mentioned, prevention is key. Prevention is key, and you have to kind of like address it at the introductory part. And as if you delay the process, the cost increases multifold, and to be really effective, prevention is the most cost effective and best way to deal with pests. And EAB is another example. Like the costs currently are exceeding 10 billion with regards to removal and replacement of ash trees damaged and killed by this one insect. And continuing on, I'm talking about a little bit more about the risk prevention strategies. We focus on the pathways in some cases, we focus on partnerships, and we promote compliance. And we do, for example, at the border mitigation, at origin mitigation, and we do the post-border mitigation. With at origin mitigation, we focus on import requirements, treatment systems, certificates, the phytosanitary certificates I talked about, establish pre-clearance programs with trading partners. We do audits, and we do education and outreach. And then at border, CBSA is the main contact point. They do inspection of wood packaging materials and soil. And CFIA is involved with the document review and sampling. And we also do outreach with regards to border lookouts and blitzes. CFIA's inspection at destination, regulatory responses, lab analysis, and then most importantly, domestic movement restrictions as well. When a pest is established recently, we kind of like try to control the regulated area and reduce the domestic movement. And of course, education and outreach. And education and outreach is a major important component of CFIA's program with regards to dealing with pests. You would have probably seen the Do Not Move Firewood campaign that has been happening for a number of years. And it is really effective with regards to controlling the movement of pests. And then we are also present in social media with regards to Facebook. And like Erin mentioned, we do the pest cards, and we are also on Twitter. And then we link up with other organizations like iNaturalist with regards to identifying pests. And some of the other aspects of CFIA's plant protection tools includes, like we mentioned, prohibiting any person from moving, growing, raising, culturing, or producing pests or infested things. And also anything suspected to be a pest or infested with a pest and is a biological obstacle to the control of a pest. The authorities include entry and inspection, removal and destruction of unlawful imports, prohibitions and restricting movements of persons or things, declaring places that are infested, and also focusing on compensation. With major pests like Asian longhorn beetle, we have done compensation programs as well if the need arises. And getting into, again, focusing back, looking at the regulatory updates that I wanted to talk about for specifically Ontario, we could categorize them into three areas: eradication and deregulatory updates, expansion and new regulatory updates, and current and upcoming consultations in the regulatory phase. So this is again a happy news story, and we're going to hear a little bit more detail with regards to the partnerships that went into this particular pest. So we declared eradicated from Canada on June 9, 2020. But then what does it mean for the public and stakeholders in the regulatory space? This is conveyed through two specific directives that we deal with, the D1105, which focuses on non-manufactured wood products like logs and non-propagative materials, and the D1101, which focuses on plants for planting and propagative materials. So we have two directives that deal with. The D1101 is a little bit more general in nature. It focuses not at the species level, but at the genus level. It focuses on the genus Anaphora in general. So some of the updates that we did, removed the domestic movement restrictions in Ontario, in the cities of Mississauga and Toronto, and also expanded import requirements with a new find in South Carolina with regards to Asian longhorn beetle. So import requirements were added for South Carolina as well. And in addition to ongoing eradication efforts in the US, in New York, Ohio, and Massachusetts. Pine shoot beetle is another good news story. And we talked about eradication, and this one is another thing where we choose not to act anymore, and it's called as deregulation. And we have to notify when we do a deregulation as to why it is not considered a quarantine pest anymore. And so this particular pest has been introduced into Canada more than 40 years ago. And initially, when it was introduced, there was concern that it would be a major pest of pine, and we do deal with a lot of pine products, and it would cause already threatened white pine even more with regards to invasion by this pest. But then as we collected data, we kind of realized it attacks and behaves more like a secondary pest and kills only sick and dying trees. And even in plantations where Scots pine, its most preferred host is present, it focuses only on dead and stressed trees and acts more of a secondary pest, more involved with the recycling of the forest. So we again worked, like I mentioned previously, bilaterally with the United States in this particular pest file. They took the similar regulatory approaches so that we could harmonize our import requirements on pine products. And we consulted on it, and the consultations are captured under the pest risk management document, and it is available on our website. So this is another way our tools apply. Initially, it was considered as a quarantine pest, but then we deregulated it based on available information. So it's a constant process. Emerald ash borer is another one where we are still focused on regulating and expansion of the regulated area. And as you know, it was introduced in Southern Ontario in 2002, and you can see the gradual progression of EAB through Eastern Canada. And the most recent expansion happened in New Brunswick, where multiple sites were found in Ormocto and Moncton. So we had to regulate a broader swath of New Brunswick. And another major regulatory change that happened with regards to EAB was the deregulation that happened in the US. US has moved ahead and started focusing more on biological control, and they have deregulated EAB based on their cost-benefit analysis. So at this point in time, we kind of like maintain both between the US and Canada, we kind of like still maintain the same import and export requirements, but we had to do some minor changes with regards to our import requirements. We used to regulate only 35 US states for EAB, but with the deregulation happening there, we have no control of knowing how the surveys are happening. So we had to regulate all the 50 states. So now what would happen is the individual states in the US will have to come up with their own monitoring and survey programs and say that they are having areas of pest freedom that we could recognize. And so the import requirements will again change based on our negotiations with them. And gypsy moth was another thing that saw a major change this year with regards to expansion of regulated areas. And this was again based on a consultation that happened last year. It was based on two major factors. One, survey showing that all life stages of gypsy moth were present in all parts of Quebec, New Brunswick, Nova Scotia, and PEI. And also host availability, the range of host availability for this pest had already been reached. So based on this activity, we expanded the regulated area for gypsy moth, and we also updated other minor updates that focused on nursery stock and restrictions, reminding of the restrictions that are in place for outdoor household articles, recreational and personal vehicles, and equipments. And this was an existing requirement, but these had to get changed or included in the directive, specifically with regards to movement of outdoor household articles and movement articles. And it also focused on, it was a much needed timely update that was needed, as this has been an outbreak year in Ontario, as you might know, and with COVID-19 restrictions, people have been using a lot of recreational vehicles and RVs and moving around the country, and they need to be more aware that they don't carry any life stages of gypsy moth, especially when it's an outbreak year, and move these pests across the country. And our aim with gypsy moth is to still protect all of Western Canada as it's currently uninfested, and any movement from a regulated area, which is in yellow here, into Western Canada would have to meet these requirements of moving, you're basically moving from a regulated area to an unregulated area, and have to follow the rules with regards to making sure that you don't carry any life stages. And we're doing a lot of outreach with regards to that. And the nursery stock, I don't know whether I mentioned, but the nursery stock deals with, the definition deals with calling it woody trees and shrubs, and they are important to be regulated because the female gypsy moth could lay eggs on the nursery stock, and the nursery stocks could move out of the regulated area with the infested life stages on it. Hemlock we have already touched on, and the ministerial order was updated on May 28th of 2020 this year, and the map is updated and the directive is updated. And moving on, let's focus on some of the consultations that you can look forward to with regards to engaging with the CFIA. And with regards to HWA, there will be a consultation happening in 2021. And we talked about high risk periods and low risk periods. Currently, the high risk period is from March 1st to July 31st, and the low risk period is from August 1st to the last day of February. But more than 2 years of data has shown that the crawler period seems to extend into August in Nova Scotia, and thereby the risk period should also be revised and updated to focus on reducing movement of regulated articles, or to be more aware of the high risk period that you are in when you're moving regulated articles. And there will be a consultation on emerald ash borer as well, and this is in response to the US domestic deregulation that happened, and theirs was also based on an economic analysis, and we did an economic analysis as well with regards to regulation and efficacy of regulations for EAB in Canada, and that has been completed. And it says the efficiency of regulations is good for EAB at this point in time, but still it does not totally reduce the spread of EAB. It does happen due to human assisted or movement of regulated products in some aspects. So we are updating the pest risk assessment again. It is another periodic thing that we do after a number of years. And we are analyzing it based on the economic analysis, the biocontrol options that are being developed currently, climate change, and of course the US developments and the need to more align ourselves with our trading partner down south. So the consultations to review and initiate the discussion to explore options around the future of regulation of this pest will be undertaken in 2021, 2022. So look forward to it. And another consultation that was recently completed was with regards to dunnage. Dunnage, as you know, is something that is used to secure or hold a product in place, but it essentially does not move with the product like a wood packaging material, but is a type of wood packaging material that is just used to secure the product, and it's usually used in ships or in cargo areas of planes. Shipborne dunnage is a major concern for CFIA, just so because there is intermingling of ISPM compliant, the international phytosanitary measures that I talked about, ISPM compliant dunnage and non-compliant dunnage, and there is always a risk when there is segregation that happens. So currently CFIA recognizes all dunnage as being non-compliant and that isn't compliant or promote ISPM 15. So this new program proposes a uniform approach for disposal of dunnage where there will be segregation of non-compliant dunnage and mandatory discharge and also a robust enforcement strategy. And reuse of dunnage will be allowed, but it will be still very restricted only in the low risk periods. And this will be based on data on program compliancy, data on dunnage compliancy. And once we have confidence, there might be a possibility to expand reuse of dunnage. And after this, the second part of this would be updating the policy or the plan and the directive. And that would happen in the fall of 2021. So in summary, you had a chance to look at CFIA's mandate, which includes plant protection and protection of Canada's plant resources. And as you know, plant protection is fundamentally different from food safety or animal health and has its unique challenges. And CFIA is Canada's national plant protection organization, and the Federal Plant Protection Act and regs provides us the tools that we can use to manage quarantine pests in import, export, and also in the domestic pathways. And with that, just about done. And questions, and you have my email. Thank you.
Thank you very much. That was a great job by everyone today. Kathleen, Michael, Erin, and Arvind. Really appreciated you guys talk today, and I really hope that everyone enjoyed this discussion. We do have a few questions that came up in the question box that I'm going to ask the panelists and see if they can help answer them. So one of the first questions in the question box is about molecular techniques for detection of HWA. So the question is, given the potential for molecular techniques in the early detection of pests, have you considered introducing molecular-based detection techniques as part of the biosurveillance program already in place for HWA? So I think that question might be directed towards Erin or someone.
Yeah, sure, David, I can take that if you can hear me. So with respect to our survey method, because we, if it's detected in an area outside a regulated zone, we would need a viable sample to be confirmed in our lab. We do have other projects running, pilot studies where we're looking at molecular potential as far as eDNA analysis, simply screening our trap fluid that we use for a different survey, our invasive alien species trapping survey, as a means to detect HWA and other potential regulated pests through passive collection and then molecular analysis of the contents. Mark Whitmore at Cornell is doing a lot of great work that's made substantial progress on eDNA analysis specifically for HWA, using techniques to basically assess trees for DNA of predators as well as the HWA individuals. So although we're not there yet, there may be future potential to establish a bunch of systematic sentinel areas where we passively monitor and then collect the material for eDNA analysis.
Okay, thank you very much. The next question that we have is, what's the average duration of time after infestation before mortality occurring in eastern hemlock?
I could answer that. This is Michael. I mean, we don't really know for sure for Nova Scotia or Ontario for that matter. It can be as fast as 2 or 3 years from what we know in the States, but I think it often is then combined with really drought-prone sites and extra stress on the trees. But just from seeing the patterns in Southwest Nova Scotia, that actually is a landscape that has fairly thin soils. There's granite bedrock really close. It's all formerly glaciated area. And there have been a number of droughts in recent years. I wouldn't be surprised if even in Nova Scotia, we would see mortality within probably 4 or 5 or 6 years, depending on the site. We definitely see complete branch decline within a couple of years. So we know that, but it's quite difficult to know when the insect arrives. So it's always a little uncertain how that timeline works. Certainly of interest, though.
Okay, thank you. One more question that popped up in the box is there any linkages between HWA and forest fires? And is there any possible data of this linkage with HWA posing a increased risk?
I'll speak to that as well. It actually came up in our recent working group discussion because I do think that it's a fairly significant risk. The mortality will be, I think, quite protracted. So it won't be, the situation where you, for example, in BC with mountain pine beetle, you would have relatively fast dieback of many trees within a stand within a year or two. I think it'll be probably a bit more gradual, but at some point in the future, I think there'll be significantly large tracts of forest containing dead hemlock, and it definitely will contribute to the fire risk, especially if we have droughts coinciding with that. I'm not aware of too much on that from the United States, where hemlock is also in a lot of places in kind of a different spectrum of sites. It tends to be more on moist north-facing slopes or in sort of shady, cool ravines, riparian zones. So I think their situation has been a little different. Perhaps in places like upstate New York, it might be getting similar to what Ontario or Nova Scotia would be facing, but it's definitely a risk. And we anticipate that that will be a major impact of the dieback.
Okay, well, thank you very much. If you have any other questions about this talk or for any of our other organizers, we should direct the questions to them. You can either email us at the Invasive Species Center info account, which is info@invasivespeciescenter.ca, or you can email any of the panelists that we have directly for future questions. As to that, our next session is on Asian Longhorn Beetle in the GTA, so the Greater Toronto Area, and that will be starting at 3 o'clock. So if you wanted to go and go for a bathroom break or grab a glass of water or coffee or something like that, then that will start at 3 o'clock very shortly. So I wanted to thank everyone for attending. It's very much appreciated. And we'll be moving on to that session next. So thank you very much, and thank you to our panelists.